So experiment 2, colligative properties. I'm just going to cover how you do the calculations. And so first you're going to determine the freezing point. You're going to take the data you got from the lab, you're going to put it in Excel, and you want to adjust the axis. You can double click on the axis or right click on the format it, zoom in on the inflection. You don't show all the data you collected. You want to highlight that inflection is what you really should see. And then you want to label your axis units, have a title, have a caption. Generally in a caption, the title is really simple. Don't just read the axis. Those are terrible titles. Think about like what's the point of it. And then in the caption, now you can have a little bit more about the quality of the data or the take-home number, something like that. All right. So here, I would just overlay a line on this by inserting the shape and see where those lines cross. If you really wanted to show off your mad Excel skills, you would actually do 3 plots in one, have one with the whole thing, one with just this portion of it that I would fit to a linear trend and let it extrapolate. Do the same thing with this linear portion and back extrapolate. And now you can clearly see where those two lines cross. Rarely people do it, but sometimes they do. Okay, so here it talks you through adjusting it and zooming in, those kinds of things. At the end of the day, I would make one nice plot, copy and paste it, and then change the data, make your other plots and adjust them accordingly. So, but you can easily just make 3 plots. You're going to determine the freezing point for each of them and then calculate the average. And then you're going to research the literature value and calculate the percent error. Should be the same as last time. So now on to part 2. It's the same thing. You're going to plot your data, get the average freezing point, and then using that, we can solve for that KF. In the relationship, you're going to have the freezing point of the standard solution, that tilde, and then minus TF for the solution. So that gives us delta T. That'll equal I KFM. And so we can find out by looking at the solute that we're adding. And then molality, now you just look at that formula and you should have these numbers. You have the grams of solute, so you can convert that to, since you know the identity, you can convert that to moles. And you have the grams of your cyclohexane, so you can convert that to kilograms, so you can solve for this value. So easy algebra to solve for KF. All right, here we go. This is what it says in the lab. Make 2 plots, find the average, calculate the freezing point depression, then use those to find the also find the moles of the ethanol, find the molality, and now with all of that, you can solve for KF and clearly show your work. On part 3, very similar, but a little different. So we're going to find the molar mass of the unknown. So again, we use the same equation that we're going to have the freezing point in part 1 minus the freezing point in part 3. That gives us the delta T, and we use the same relationship. We don't know the unknown, so we'll assume I is equal to 1 here. KF, that's what you solve for part 2, so you can solve for molality. Then once you get that, you can rearrange and solve for the moles of the solute. So we know the mass of it. So we know the mass of the solute, but we don't know the molecular weight because it's unknown. So we take the molality value times the mass in kilograms of the solvent, and that allows us to solve for moles of solute. To get to molar mass, then you simply take grams and divide it by the moles. So here again, you make plots, calculate the average freezing point. Now find the molality using the KF value in part 2. And here you take the step to calculate the molar mass. So the equation molality will allow you to calculate the moles. This number, along with the mass of the solute, will allow you to calculate the molar mass. Okay, so that's it. The post-lab questions should be rather straightforward. One classical colligative property calculation, and another one kind of communicating your thoughts on data and error.